So Bharat centered. Yesterday we ended the lecture with some question, right? Um, is Bharat there? Am I audible?
Yes, sir. Good morning, sir.
Good morning. So for example, yesterday we were doing this question, right? If I'm not wrong, okay. So divided by I think e raised to power z minus one. And it was asked that it has a simple pole. It has a simple pole at z is equals to 2k n iota and essential singularity at essential इसको देखना था कि was it a true or a false statement, right? At z equal to 1. You have to see whether the statement was right or wrong. Okay. So let us begin. Okay. So what you can do for this question is probably you can write each of these things in a series form. So that would help you. So e raised to power z minus 1 will give you z plus z square upon 2 factorial plus z cube upon 3 factorial, so on and so forth. Okay. But this particular portion would actually become what? So e raised 1 upon z minus 1, e raised to power. This will give you 1 plus 1 upon z minus 1 plus 1 upon 2 factorial 1 upon z minus 1 का whole square plus 1 upon 3 factorial z minus 1 whole cube, so on and so forth. So what you will end up getting, you'll end up getting this thing. Okay. So what you'll get, I think you'll get 1 upon z plus z square upon 2 factorial plus z cube upon 3 factorial. This will be on the denominator's end. Okay. And on the numerator end, what you will have 1 plus 1 upon z minus 1, 1 upon z minus 2 factorial, 1 z minus 1 factorial plus 1 upon 3 factorial z minus 1 whole cubes and so on and so forth. Okay, so what you're finding that yes, no, indeed z equal to 0 is singularity. Okay, so that I'll count in this. Okay, so that I will count in this because here I will say that n belongs to z. So I'll count n equal to 0. So z equal to 0, I'll count here. Don't think about that, but think about this particular bracket. Okay. So in this particular bracket, you can see that 1 upon z minus 1, 1 upon z minus 1 whole square, 1 upon z minus 1 whole cube. And this is an infinite series, isn't it? So this is an infinite series. And you cannot associate any pole of definite order. So you cannot associate a pole of definite order. Do you understand what do I mean? Pole of definite order. Let's say if I say if z equal to 1 is a pole of, let's say, order n. Okay, let's say if I say that z is equal to 1 is a pole of order n, then this limit with regards to this function fz I'm saying should give me a non-zero scalar, non-zero finite scale, isn't it? But what would happen since it is an infinite series? So, okay, that would be fine. Let's say z minus 1 raised to power n. All these terms, 1 plus 1 upon z minus 1 plus 1 upon 2 factorial, z minus 1 whole square, so on and so forth would do. But the only point is, beyond this, you will have some powers of higher powers of n and n plus 1 and so that would get cancelled, and here you will have some terms in the denominator's end, and as z equal to 1 these will tend towards infinity, so clearly it will not give you a non-zero finite scalar for any n, as even you take as large as n. Further, you can also see that this is not a removal singularity, because for removal singularity, your limit should exist. So limit z tends to 1, e raised to power 1 upon z minus 1 will give you infinity. Okay. So in any case, both of these possibilities are rejected. So for z equal to 1, z equal to 1 is neither a pole of a definite order, nor it is an essential singularity, nor it is a removal singularity, which leaves us to the conclusion that z equals to 1 is an essential singularity in this case. Yes or no? But you cannot escape this singularity in any means. Are you getting my point till now? Does anybody have any problem? Should I proceed further? Okay. So let's say, what about z equals to 0, or let's say other things that may also arise? Why they may arise? See, here clearly z equal to 0, you can clearly see that this is singularity. Why I did not discuss it? Because I have to discuss it in this portion. Okay, so therefore now I'll discuss. So again, coming back to the original function, the function is, so fz is equals to, I think it is e raised to power 1 upon z minus 1 upon, I think it is e raised to power z minus 1. So another kind of singularity would arise from this portion. E raised to power z is equal to 1. This kind of singularity will arise from this portion. Okay. So e raised to power z equal to 1 means what? E raised to power z equals to 1 means e raised to power z is equals to e raised to power iota to n pi, where n belongs to this. Okay. Everybody is clear about it? Has किसी को कोई प्रॉब्लम है इसके अंदर? We just use the, क्या कह सकते हैं, e की पर iota theta is equals to cos theta plus iota sin theta. You will be able to understand what I'm writing, right? Okay. I hope it is clear.
Yes, sir.
Okay. So what? So clearly z is equals to iota 2n pi are also singularities. Okay, so these are also singularities. So obviously n equal to 0 case will come here. So that is why I did not discuss it. So what kind of singularities are these? I mean, question arises, what kind of singularities are these? So for, in order to understand, obviously when today probably we'll start with Taylor series, and by tomorrow we'll do Laurent series also. So we'll see all these singularities in the light of Laurent series also. But for right now, what do we do? We'll do something from the calculus that we did in our junior classes. So in our standard 11th or 12th classes, you might have seen this kind of limit, and this limit turns out to be 1. Even if you don't know, even if you don't remember, you just expand this term. You'll be able to understand why I'm writing it as 1. Okay. So what needs to be done? And you also know that e raised to power iota 2n pi is 1. So you can do a manipulation, and that manipulation would give you 1 upon e raised to power z minus 1. That is fine. I have no issues about it. So z equal to 1 is an essential singularity. What to do? E raised to power z minus 1, just play with it. I mean, you just do one thing. You just write e raised to power z into e raised to power minus iota 2 n pi. Why I'm doing it, I'll explain you. Okay. Does anybody have any problem till now? See, e ki power iota n pi is 1. So e raised to power minus 2 iota n pi would also be 1. So there's no problem regards this. I'm just multiplying it with 1. And instead of 1, I'm writing this. Any issues? Standard 11, 12, nothing more. I mean, standard 11 to 12, you've gone through all these kind of manipulations. And so that is what I'm doing. So, okay, in order to justify that my iota 2 n pi is a simple pole, if I'm saying that iota 2 n pi is a simple pole, say let's say that is my claim. So I'm claiming that iota 2 n pi is a simple pole. What am I supposed to do? I'm supposed to do this. I am supposed to prove that as z tends to iota 2 n pi, z minus iota 2 n pi, z minus iota 2 n pi raised 1 into fz, which is your case this. So I'll write it. I'll write it this way. Fz should give me a non-zero finite scalar. Okay, so if I'm saying z is equal to iota 2 n pi is a simple pole, then what am I supposed to do? I'm supposed to do this kind of operation, and this kind of limit should come out as non-zero finite scalar. Okay, so what I would do, I would prefer, why did I write this? You might now be able to understand why I wrote this particular thing, or probably why I made this kind of manipulation, or this kind of maneuvering while doing all these things. So what I'll do, I'll simply write this in this fashion. This numerator part has no problem as such. This portion I will put in the denominator end. So for example, if I'm saying x, can I not write it as 1 over x? So what I would do, I would take this thing in the denominator and in the denominator on the denominator. So what I would do is, so if I'm saying this is multiplied with fz is this. So what I would do is, I would simply do this z minus iota 2 n pi minus 1 divided by z minus iota 2 n pi. So you just write n here. Okay. So this is the limit. Now, it is fairly easy to see that iota 2 and pi, when I put here, it is tending to 0. When I'm putting at z tends to iota 2 and pi, this is 0. And please remember the limit that I wrote here. As z tends to 0, e raised to power z minus 1, e raised to power z minus 1 divided by z is 1. So this entire thing will become 1 as z tends to iota 2 and pi. Or if you are not that convenient, put this z minus iota 2 and pi as some other, let's say zeta. So what you'll do, I can write as zeta tends to 0, e raised to power zeta minus 1 upon zeta. Because as z tends to 2 and pi, zeta would tend to 0. And zeta would tend to 0. This entire thing is e zeta minus 1 divided by zeta. Zeta tends to 0. This will become 1. And what you are left with, you're left with simply 1 over e raised to power iota 2n pi minus 1. Isn't it? So this is z minus 1. Are you getting my point? This is z minus 1. Okay. And you can write e raised to power z minus 1 as e raised to power z into e raised to power minus 1. So this will become e raised to power e ऊपर आएगा और sorry, this z is iota 2 and pi. So this is 1. Certainly non-zero. So clearly I can say that z is equals to iota 2 and pi are nothing but simple poles. These are nothing but simple poles. And right away I can say that z is equal to 1 that I discussed in the very initial part of the lecture is an essential singularity. So indeed this statement is true. So yesterday I gave you this particular question as homework. Okay, should I move ahead? Okay, so next
Yes, sir.
question. Bharat, समझ में आ गया था?
हाँ जी सर, yes sir.
Okay, so let us move ahead with a few more questions. And things would become easy once you will go through Lorentz series. So probably from today itself, I'll start with Taylor series, and probably by tomorrow I'll end up by Lorentz series. The only problem I was seeing in physics was just let me get done with a few things in complex so that we'll do questions. And while we are doing questions, we can go ahead with physics things. Because right now there's too much of theory that is left here. So that is why I refrained from starting that particular thing. Okay, we'll do that for sure. Don't worry about it. Okay, so let us do a few more questions on this kind of concept because you should be able to understand. You should be able to understand right now because these are all. अच्छा मुझे question का जवाब दो. Uh, do you really think? Yesterday I was doing a question. Now on the very same line I'm asking. Do you really think? Do you think z equal to 0 is a branch point? Is a branch point for the function? For the function that I'm writing right now, e raised to power root over z minus e raised to power, I think this would be minus z divided by sine root z. If I'm not wrong, this should be the question. Okay. Try to, uh, like, what do you think? That z equal to 0 is a branch point or other point? What do you think it is? Anybody has any answers to it? Do you think that z equal to 0 is a branch point here?
Seems not, sir.
Seems not, right? So yesterday we were doing on the very same lines. I'll go ahead with that. So let us start with making a contour about z equal to 0. Okay, so what has been asked at z equal to 0, does this function has a branch point? So what I'll do, I'll simply take a point A and I'll simply write it as r comma theta. So when I write it as r comma theta, what will become? It will become r raised to power 1 over 2 e raised to power iota theta by 2 minus iota minus r raised to power 1 upon 2 e raised to power iota theta by 2 divided by sine root over r e raised to power iota theta by 2. I don't think anybody has any issues. But what will happen after one revolution? After one complete revolution, theta would change to theta plus 2 pi, and this entire thing will become e raised to power minus root over r e raised to power iota theta by 2. I don't think now I need to prove all these things. You might be aware, like if I put 2 pi here, so iota 2 pi by 2, it will become iota pi. This will give me a negative, and this negative will get absorbed to positive overall. And overall, if you'll see that inside sine, this is a negative, negative will come out. So this will become sine root over r e raised to power iota theta by 2. So negative comes out. It will make this as, sorry, I will write. So this is a negative. And when negative, if I multiply on the above side, on the numerator side also, what I'll get this way. The numerator will become this divided by sine root over r e raised to power iota theta. So even after one revolution, the value remain the same. So this is, you're not getting two different values. Okay. So for root z, you mostly expect that root z is a multi-valued function. Yes, indeed. And it has two branches. But here you can see that there are no such two branches. The value of the function is exactly the same, even after one revolution. Or you probably take two revolution, three revolution, whatever. In any case, the value would remain the same. So therefore, this is not a multi-valued function. Since this is not a multi-valued function, so I would write that this is a z equal to 0 cannot be a branch point. Z equal to 0 is not a branch point. Rather, you will find that this is a removable singularity. Yesterday, I discussed the very same question. On the very same lines, I made this question. So you just try to find, I think z tends to 0. You'll find that if I write e raised to power z minus 1 minus e raised to power minus root z minus 1. Okay, this was it, I think. E raised to power z minus e raised to power minus z upon, I think sine root z was there, no? So sine root z. You just multiply with root z, divide by, just divide by root z, and also here place divide by root z. Okay, so what I did, now this particular limit is 1, this particular limit is 0, this particular limit is again 1. I'll write it all over again. So this will be a limit z tends to 0, e raised to power root z minus 1 divided by root z, okay, minus e raised to power minus root z minus 1 divided by root over z. And what you do, you just take this negative from here and just multiply here, divided by sine root z divided by root z. So what we'll get, this limit is 1, this limit is again 1, this limit is again 1, so this will give you 2 upon 1, that is 2. This is a limit. So obviously, if I'm saying that at z equal to z naught, limit z tends to z naught if z exists. If z equal to z naught is a singularity for fz and limiting value of fz exists, then z equal to z naught, or here in this case, z equal to 0 is called as removable singularity. So you'll be surprised to find that this is a removable singularity, not a branch point. Okay, so such questions may be asked in your interview or examination somewhere. So you kindly keep these things in your mind. Okay, let us move ahead and do a few more questions that we left yesterday for homework. I think, what about this question? This question probably I gave. This was fz is equals to ln z minus 2 divided by z square plus 2z plus 2 whole raised to power 4. Okay, so what about this question? What can you say? What are the kind of singularities it does have? So clearly you can see that logarithmic function is singular at z equal to 0. Okay, so here the displacement is, sorry, for example, here you have z minus 2. So z equal to 2 is clearly a branch point. And what kind of singularity is branch point? This is a non-isolated singularity. And what about these guys? I mean, what happens about this? So you just simply solve this equation, 2z plus 2 is equal to 0. What you would get, I think, z is equal to minus 2 plus minus root over b square minus 4ac. So this is 4 minus 4ac. This is 8 upon twice. So that is, you will get z as some alpha and some beta. Alpha will be -1 plus iota upon, I think not iota, another will be -1 minus iota. So what you are getting, fz can be written as ln z minus 2 divided by z minus alpha raised to power 4, z minus beta raised to power 4, and alpha and beta are these guys. So alpha and beta are nothing but are the poles of order 4. You can simply verify them by the same thing that I did above. Simply multiply it with z minus alpha raised to power 4. Let me do it also. Let's say if I'm saying this is a pole of order 4, then what am I supposed to do? I'm finding the limit z tends to alpha, z minus alpha raised to power 4 into this entire thing. This gets cancelled. Z tends to alpha, it will give you ln alpha minus 2 divided by alpha minus beta raised to power 4. So alpha minus beta, what you will get? I think iota plus iota is 2 iota, and 2 iota raised to power 4 will give you 1/16, and this will be equals to ln. Alpha is -1 plus iota, so this will give you -3 plus iota. Certainly, this is a non-zero limit. This non-zero limit is coming when I'm multiplying the entire function by z minus alpha raised to power 4. So z equal to 4, z equals to alpha is a pole of order 4, and similarly you can verify the same for z equals to beta. I hope it is clear. Does anybody have any problem? कोई कुछ तो बोले यार, क्या हो गया, एकदम शांति क्यों छा गई? Anybody has any
नहीं
problem?
भैया
Okay, okay.
नहीं
चलो चलो. What about this question? So ये ना, मतलब अभी हम लोरेंस सीरीज करेंगे, शायद आज आज कर पाए तो कर पाए, नहीं तो कल तो करेंगे for sure है. So probably from tomorrow things will become slightly easy for you. So once you have Lorentz series in your hand, you will be able to understand. See, if you're not able to understand what sort of singularities are there, you will not be able to find the correct residues for them. And if you're not able to find residue for them, you will not be able to do integral. So kindly pay attention to this particular portion. Even if you are not able to follow stereographic projection, or probably even if you're not able to follow field or anything of that sort, which requires much of mathematical rigor, even if you follow all these things, one, analytic functions, second, the nature of singularities and type of singularities, and how to find singularities, you are done. Like in physics, you are done. You are not supposed to, even if you're not getting what is field, it's absolutely fine. Okay. But now जो ये अभी कर रहे हैं, ये तुम्हें समझ में आना चाहिए. Otherwise, things will become difficult while you will do integration. Because integration would require you to understand what all these singularities are. Because if you don't understand what sort of singularities are these, then things would become difficult indeed. So what about this particular function? What do you think that in finite complex plane, what sort of similarity does it have? So if I just find, so अभी 2 मिनट पहले हमने निकाला -1 plus minus iota, these will become what? These will become simple poles. Again, I would do like you just equate it to 0. You will get two roots. This is alpha and this is beta. And your function is z square minus 3z divided by z minus alpha into z minus beta. So understand my point. If you are given ax square plus bx plus your any even nth order polynomial, you can always break it into, you can always factorize it in terms of your roots. So this is something that you know from elementary class. So if I am having a, let's say, quadratic equation, I can write it in the fashion, or I can write it in the manner, I can factorize it in terms of two factors, which are nothing but which consist of the roots. Like, so alpha and beta are two roots. So I can write this entire thing as z minus alpha into z minus beta, the denominator part. Now what would happen? What is z minus alpha? So z minus alpha raised to power 1, z minus alpha raised to power z minus beta raised to power 1. So what you'll do, simply multiply, find this limit. So what I've done, I've simply multiplied z minus alpha to the fz. So fz is this. So fz is this. So z minus alpha gets cancelled with z minus alpha, and you're left with alpha square minus 3 alpha divided by alpha minus beta, and it is fairly easy to see that this is non-zero. So z minus alpha when multiplied with fz and limiting value z tends to alpha gives you a non-zero value, implies z is equals to alpha is a simple pole. This is a simple pole. Indeed, you will find that beta is also a simple pole. Okay. Does anybody have any problem?
No, sir.
Okay. So what about next portion if I go? So a few questions we'll do for extended complex plane also today. But let us first uh, do a few more questions on. So itna kar loge, it is sufficient. And on group, I have group. I think Alpna has already shared a PDF for mathematical physics. I think you are old enough to understand what all questions are for complex. Kindly go through that entire PDF and find what all questions you can do right away, like with the knowledge that you have till now. Not integration. Integration will teach you, and then you will have to do. But overall, you try to do all those questions which we have done, whose concepts we have done till now. Okay, so that will boost your confidence. So what about this question? I hope I have given it yesterday. If I have not given it yesterday, try to do it. What all singularities are here? And give me the name of the singularity also. I mean, type of the singularity. So it's fairly easy to see that logarithmic. I'll also go through one of the concept called as Riemann sheet, and I'll also teach you people also in brief, not very detailed, but Riemann sheet also I'll teach you once I'm done with the entire thing. Right now, tell me what are singularities are here. So you can clearly see that z is equal to. So you can clearly see that this is, I think, z. Sorry, not 3. This is z. So z is equal to minus 2 iota is a branch point. Yes or no? Logarithmic branch point. So whenever logarithm is a multi-valued function, and I have stated on the very first day that z equal to 0 is a branch point for log z. So instead, if I'm given z plus 2 iota, just see where it becomes 0. So it becomes 0 at z equals to minus 2 iota. So minus 2 iota is a branch point. And what about z square? So z square will become, the condition for singularity for this particular thing would be that numerator becomes 0. So z equal to 0 is a double pole or pole of order 2, whatever you feel convenient with. I hope it is clear. Should I move ahead?
Yes, sir.
Okay. What about this singularity? I think sine inverse 1 over z. What sort of singularity is 1 over what sort of singularity is z? So what you can do, you can clearly see. लेट्स से एक तरीका मैं सिखाता हूँ तुमको हाउ टू गो अबाउट. अगर बिल्कुल ही नहीं समझता आता एग्जाम में तो क्या करो, इसको ऐसे लिख लो एक बार को. आई एम जस्ट गिविंग यू वन हिंट कि how to make Taylor series expansion. Right now, if you will start differentiating it, it will become very difficult for you. See, Taylor's expansion is unique. Understand that Taylor's expansion is unique. I will come to Taylor's expansion, but थोड़ा सा बचपन से याद हो तो मैं बोल रहा हूँ Taylor's expansion is unique. So for example, instead of sometimes if you are not convenient with the idea कि Taylor series क्या कैसे निकालें, what you do, you just do some a trick that I'm telling you. This is a sort of trick that you know. You know binomial expansion. So what you can do, you can clearly see that derivative of this particular function will come as 1 over root over 1 minus x square. Any issues regard this? Okay. And what you can do, you can, I'm just giving you a suggestion. I mean, this is not exactly what you should do, but right now I'm not remembering what is the expansion for this. So I'm just trying to convince you by doing this. So what you can do, you can simply differentiate it, and you can fairly see that y0 is 0. That is, at x equal to 0, y would become 0. Differentiate it, and 1 minus x square raised to power minus half. Okay. Uh, for mod x less than 1, so for mod x less than 1, you can expand it in the Taylor series. In the binomial series. So for mod x less than 1, you can expand it in the binomial series. And you'll say me, why are you doing only for mod x less than 1? Because the domain of the definition suggests me to do so. So here 1 minus x square has to be positive, which eventually would lead me to mod x less than 1. And also understand the binomial expansion can only be possible if mod x is less than 1. Okay, you just write the expansion to this. So expansion to this will be x square by 2 plus n into n minus 1. So this will give you 3 by 4, I guess. N into n minus 1, or I think एक मिनट यहाँ लिख ही लेते हैं ना, 1 plus x raised to power n is 1 plus nx plus n into n minus 1 divided by 2 factorial x square and so on and so forth. Okay, so what you'll get, minus 1 by 2 into minus 3 by 2, and uh, you can write it as in this fashion. So instead of minus, you just write it as plus and give a minus here, so that things will become easy for me. Okay, so now it is 1 plus nx. So n is minus half, x is minus x squared. This will become plus. Then 3 by 4, some x raised to power 4 and so on and so on. Okay, so what you can do, you can integrate it, because you are supposed to find y now. Y to sine inverse x tha, integrate it. So what you'll get x is y is equal to x plus x cube upon 6 plus 3 by 15 x की power 5 plus some constant of integration. At x equal to 0, y is 0, so your concept of integration dissolves. So what you can say that your sine inverse x can be written as x plus x cube upon 6 plus 3 over 15 x raised to power 5 and so on and so on. So how your sine inverse 1 by z would behave? So the Taylor series remains the same for complex and real. Only part you can do in this fashion. Now looking over it, tell me what would be your z equal to 0? What sort of singularity is z equal to 0? It is an essential singularity. Yes or no?
Yes.
No, because you cannot associate a pole of definite order. If you multiply it with z raised to power 4, let's say, so z raised to power 4 when multiplied with this give you z cube. Z raised to power 4 when multiplied with this will give you some 1 over 6z, and this will give you 3 by 15. But what about higher order terms? They will also exist, and when they exist, z raised to power 4 when multiplied with them would give some terms in the denominator side, and the limit would blow up. And similarly, you cannot say that this limit exists. So neither it is a removal singularity at z equal to 0, nor it is a pole of definite order at z equal to 0, which leads me to say that z equal to 0 is an essential singularity. This was just an idea when you are not left with anything.
सर
Because see, हाँ बेटा बोलो.
सर ये 3/15 लिखा है, 3/20 होगा.
Okay, sorry. This would be. प्रभु कुछ हुआ तुम्हारा? नहीं हुआ? हो जाएगा? नहीं होगा? कुछ पता किए हो? भीमसेन कुछ बोल नहीं रहे.
यस सर.
क्या करेंगे बताएं? You apply in I think NIT Allahabad. That would be good. Okay, बाकी फिर अपन
जी
फोन
सर.
पे
सर
बाकी फोन पे डिस्कस करते हैं. ठीक है?
जी सर.
ठीक है. So last this thing is root over z into z square plus 1. What about this function? What do you think would the singularities be?
Like there are branch points.
They are branch point indeed. Okay, so there are branch points. So you have root over z here, and you have root over z square plus 1. So z equal to 0 and z equal to plus minus iota are branch point. Here you cannot escape the multivaluedness, and it's fairly easy to see. You just replace it by root over iota theta, and again you see after one complete revolution it will give you two different values, because root z is here. So you just see by doing the same exercise that we were doing. So this is a branch point. So z equal to 0 and plus minus iota are branch points here. ठीक है, आगे बढ़े. What about this question last?
सर
हाँ बेटा बोलो.
सर इस वाले क्वेश्चन में मेरे को डाउट है सर.
इस वाले में?
जी सर.
हाँ बोलो बोलो.
सर एक तो इसका ब्रांच का ड्रॉ नहीं हो पा रहा.
इसका ब्रांच का ड्रॉ नहीं हो पा रहा. ओके. चलो दैट आई
जी
वुड डू, मैं करके तुम्हें बताऊं चलेगा, दैट वुड बी
हाँ
फाइन,
जी सर, कोई प्रॉब्लम।
है ना?
और सर एक और डाउट था कि जैसे अगर हम z इक्वल टू 0 के अराउंड अगर हम कर रहे हैं,
हम्म।
तो उसमें तो हम ठीक है 0 to π डायरेक्ट ले लेते थे।
पर आयोटा का
बट अगर
बहुत
वो
नहीं हो रहा
शिफ्ट
होगा। हम्म।
आयोटा के अबाउट मतलब शिफ्टेड ओरिजिन हो गया, तो उसमें आपने बताया था ना कि एंगल इट विल नॉट गो टू 0 to 2π, मतलब वो एक लिमिटेड एंगल
यस
में
यस, वो
रहेगा।
समझ पा रहा हूँ। एक्चुअली तुम जो कह रहे हो उसमें अंतर हो गया। अगर तुम कह रहे हो कि प्लस माइनस आयोटा ब्रांच पॉइंट है, तो तुम्हें आयोटा पे रहना पड़ेगा। समझ पा रहे हो मेरी बात?
हाँ जी हाँ जी।
है ना? तब तुम z इक्वल टू जीरो पे नहीं हो। हमने जो डिस्कशन किया था उसमें हमने कहा था कि z इक्वल टू जीरो के अबाउट अगर आप रोटेट करते हो तो z इक्वल टू जीरो विल बी अ ब्रांच पॉइंट। एंड और सिंगुलैरिटी z रेज़ टू पावर 1/2 तुम्हें पता है जीरो ही है इसके लिए। और अगर तुम यहाँ मतलब तुमने अपनी डोमेन ही चेंज कर ली तो z इक्वल टू जीरो तो अब डोमेन में है ही नहीं। तो z इक्वल टू
हाँ
जीरो
जी
इस
सर।
केस में ब्रांच पॉइंट नहीं होगा। अगर
हाँ
तुम्हें
जी सर, बट
हाँ सॉरी, हाँ बोलो।
हाँ सर, बस ये पूछा था कि फर्स्ट और थर्ड केसेस में फिर हम एंगल क्या लेंगे सर?
एंगल नहीं लेंगे, हम ओरिजिन शिफ्ट करके आयोटा पे सेट हो जाएंगे। फिर हम लोग यहाँ से पैरामेट्रिक इक्वेशन बनाएंगे, दैट इज z माइनस आयोटा इज इक्वल टू r e की पावर आयोटा थीटा। सो फॉर दिस योर एनी पॉइंट ऑन द सर्कल विल बी आयोटा प्लस r e की पावर आयोटा थीटा। एंड
ओके सर।
सो उस तरीके से फिर विल बी एबल टू एक्सप्लेन कि ये शिफ्टेड ओरिजिन में आयोटा किस तरीके से ब्रांच पॉइंट है। So I'll come to this question ना, हम लोग इसका ब्रांच पॉइंट बनाने की कोशिश करेंगे। Okay, I will also tell you Riemann sheet also, but overall for a longer term you'll have to accept the fact कि बहुत बार visualize नहीं भी हो पाएगा। I would give you the answer for this particular question, but because ये बहुत lame concept है, तुम समझ रहे हो? देखो, ब्रांच पॉइंट का कंसेप्ट जब हम डिस्कस करते हैं ना मैथ्स में, तो what do we do? We say that this is your function in z, this is your z plane and this is your w plane, and if I'm saying root z, तो वहां पे हम क्या कहते हैं कि अगर आप पूरा एक कंप्लीट रेवोल्यूशन कर लोगे तो भी आप कहाँ पे आ रहे हो, जीरो से लेकर 2π तक पूरा कंप्लीट रेवोल्यूशन करोगे रूट
तो
जेड,
हाफ हो रहा है
तो ये सिर्फ हाफ ही कवर होगा तुम्हारा डब्ल्यू प्लेन।
यस सर यस
सो
सर।
बेसिकली इट विल यील्ड यू सम रीमैन शीट। तो मैथ्स में हम लोग करेंगे तो हम इसको रीमैन शीट टाइप समझेंगे। सो दिस इज वन, सो फॉर one complete representation you have a one Riemann sheet. Another revolution will give you the coverage of the lower plane. So for that you have to make another Riemann sheet for this. So uh, uh, and where those two Riemann sheet converge, that is called as a branch point. So ये चीज मैं I think I'll be able to explain you some in some later lectures. So मतलब for every I think it will be very difficult for me to make you understand what sort of topology will be of these Riemann sheets. Yeah, but for simpler cases I'll be able to explain. I would also come to your problem this way also. ये वाली problem भी हम समझेंगे. But you should understand Riemann sheet. Being from theoretical physics, someday you have to defend the range point to some mathematics audience. You should be able to understand all these things. So we'll go about it. Don't worry, and we'll also find the branch cuts for the same. Okay. So what about this particular question? This is the last question because we are running short of time. Just let me know what sort of singularities this particular function is. So I think it's fairly easy to see that z equals to minus iota
यस
would be the
सर।
singularity, and they will be poles of
ओके।
order 3.
यस सर।
Okay. Okay. So I hope we are running with we are having, तो मैं समझ गया ना भरत, तुम ये कहने की कोशिश कर रहे हो इससे जस्ट पहले जो क्वेश्चन था, यू आर नॉट एबल टू फिगर आउट व्हाट विल बी द ब्रांच कट फॉर द फंक्शन, इज इट?
यस सर। सर क्योंकि अलग अलग रीजन में मेरे को जो हम थोड़े से पॉइंट ले रहे थे एप्सिलॉन और एप्सिलॉन में पी और पी डैश मतलब कोई भी,
हम्म।
वो अलग अलग रीजन में अलग अलग वैल्यू मिल रही है सर, उसमें समझ नहीं आ रहा था कि कौन सा फिर ब्रांच कट लेंगे।
चलो लेट मी
मतलब
सी ना।
कि आयोटा माइनस आयोटा और जीरो तीन हमारे पास ब्रांच पॉइंट्स हैं, उनके बीच
हम्म।
में अलग अलग एंगल्स आ रहे थे।
ओके ओके, मैं इसको करता हूँ एंड आई लेट यू नो टुमारो इटसेल्फ, ठीक है?
जी सर जी सर।
ओके जी, चलो मिलते हैं नेक्स्ट मीटिंग।
ओके सर।